These clouds grow and merge into larger ones, rising all the time. Some of the water drops become too heavy for the updraft of air to lift and fall as rain. Are lifted by powerful air currents high into the cold upper regions, where they freeze into tiny crystals of ice. As the cloud hits the base of the stratosphere, it spreads out sideways to form the anvil shape typical of thunderclouds.
The clouds that make lightning are the largest clouds in the atmosphere. A big active cumulonimbus cloud is about as wide as it is deep, and they generate long anvils which extend horizontally in the prevailing wind aloft.
Some ice crystals build in size to form small hailstones. Scientists believe that as these hailstones fall back through the rising ice crystals, millions of tiny collisions occur. These collisions build up an electric charge, which is stored in the cloud like a battery.
A cloud is very much like a battery, but a battery with a much higher voltage than your typical flashlight battery. Not 1.5 volts, but 100 million volts.
But what scientists don't know is exactly how this electric charge generates lightning.
What remains a major meteorological mystery is how it is that ice particle collisions result in the generation of lightning. We're very much in the Middle Ages on that problem.
When observed with the naked eye, lightning appears to travel from the clouds directly to the ground. But recent advances in video camera technology reveal that the anatomy of lightning is much more complex. This is the U.S. Air Force Atmospheric Research Center in Colorado Springs. Here, Dr. Jeff McHargue is using a super slow-motion camera to capture lightning. To do this, he needs split-second timing.
Oh, darn it. It's a lot like fishing. You just have to get lucky and get the lightning bolt inside your field of view.
Success is rare, but 2 years ago, McHargue hit the jackpot.
I was simply watching the lightning get closer and closer, and I kept recording it, and I didn't know what I had until I went back and reviewed it.
For the first time ever, Jeff had recorded the birth of a lightning bolt in super slow motion. When played back, it shows a flash of light dart out of a cloud and zigzag downward in roughly 50-yard segments. This first stage of lightning is called a stepped leader.
You can see the stepped leader coming down here, looking for ground, going back and forth. You can see the tortuous channel that it's taking as it divides back and forth.
As this stepped leader gets close to the Earth, it has an extraordinary effect on objects on the ground. They respond to the strong electric field by growing positive streamers. These reach up anywhere between 3 and a few hundred feet above the ground, as seen in these rare photographs. Finally, when a stepped leader and a positive streamer meet, the electric charge can drain to Earth, resulting in the blinding flash of light we call lightning.
The entire field of view lights up. That's the main part of the lightning strike that your eye will catch.
The new generation of cameras has enabled scientists to record a strike that lasts just a fraction of a second and play it back over 200 times slower to analyze its detail. These super slow motion images show the step leader making a connection with the ground. The entire charge then drains from the cloud above, seen as a series of pulses. Using the latest camera technology, scientists are beginning to unravel the mysteries of lightning.